morning, everyone. On behalf of the Inter-American Institute for Global Change Research, the World Meteorological Organization, and the University of Colorado Boulder, we would like to welcome you to this regional seminar that will be part of a series of webinars where we will be contributing to connecting climate science with climate services in the Americas. And today, we are very happy to start this webinar regarding the application of translating advances in ENSO research to operations in Latin America and the Caribbean. We are very happy to tell you that that over 1,200 people have registered to this webinar for over 35 countries. And thank you for finding some time to participate in this relevant activity. Some recommendations, some housekeeping. We have several presentations today and quite a dynamic agenda. So please, if you have questions for the speakers, please write them in the Q&A section at the bottom of the Zoom screen. Or you can write your questions in the chat. We have simultaneous interpretation in English and Spanish. So please select the language of your choice at the bottom of your screen as well, where it says interpretation, so you can listen to either language. Also, these presentations will be shared with the audience after the webinar. We have received the approval of every speaker to make the presentations available to you. Without further ado, we would like to start this webinar by inviting Dr. Anna Stewart, the Executive Director of the IAI, to welcome you all and open the seminar. Thank you. Thank you, Rodney. Thank you, everyone. It's really exciting to see friends and colleagues from all around the Americas and the region and the world. We have so many people connecting and joining us today. Thank you so much for your interest in this important topic. The IAI aims to promote science on global environmental change so that our countries have the necessary scientific knowledge and tools to make the urgent decisions that are needed to address the challenges of global environmental change. Last year, I started working with Pedro at the University of Colorado. And through the IAI, we provided some funds to students in Latin America and the Caribbean to participate in in-person training. And we work very closely with the WMO. So we said with Pedro that this is important information. It's urgent to disseminate it. Science has advanced quite a lot. And the impact of the ENSO in the region is huge. Droughts, health, energy, agriculture, etc. So in that spirit, we have come together these three institutions to produce this seminar. This is the first of a number of exchanges in the region. Hopefully, you'll be able to ask questions, meet each other, connect, so that we can work together to translate the new advances in the area of the ENSO into the operations in our region. Thank you so much, Ronnie and Pedro, for being the drivers of this initiative. Welcome, everyone. It will be quite an interesting day and the first of many opportunities. Thank you. Thank you so much, Anna. Now I would like to invite Dr. Pedro DiNezio, who has been essential by putting together this activity from the University of Colorado Boulder. Hello, good morning, good afternoon, everyone. Thank you for joining this event. And thank you to Rodney and Anna for guiding us in the organization of this event by connecting these two worlds. We have the feeling that science is advancing so quickly regarding the ENSO prediction activities and how it impacts Argentina, Chile, up to Alaska, going through the Caribbean and Central America. Why are we organizing this event? We want to share scientific advances, but also we would like to get your feedback because you are the people who are there in the fields trying to use these forecasting systems. So I would like to invite you to give us your feedback, to tell us what is useful, what is not. We're beating about the bush, you know what scientists are like. We like to analyze every detail. So the idea today is to share useful knowledge about forecasting these impacts in the region. Thank you to all the speakers today. And please send us your comments and feedback so that we can keep improving these events in the future. Thank you. Thank you so much, Pedro. The World Meteorological Organization is very happy to be part of this effort. This effort is aligned with every process that we are implementing from the WMO and in the Americas in order to connect scientific research and the operations of national meteorological services and regional climate centers that have been working in the Americas for a long time already. Considering the importance of El Niño when it comes to seasonal and sub-seasonal forecasting and climate services developed in the region successfully, it's very important to build these bridges so that scientific knowledge can inform every operational process, the models used, and also so that we can identify remaining gaps, challenges, the huge problems we have when forecastings are not accurate, when the impacts of El Nino do not materialize as we expected, what happens with the coastal El Nino, the classic El Nino, and the Pacific El Nino, and also its impact on these sectors. This is why we're coming here today. We want to open up this conversation, listen to you, bring together the scientific and the operational communities. And hopefully this will be a great interaction. Without further ado, let us now go into the topic. Let's start with the first presentation. Thank you so much, Dr. Michelle Lheureux from the NOAA Climate Prediction Center. She will be talking about the ENSO, is climate change affecting ENSO monitoring and prediction? So this is a big question, but Michelle has a lot of experience, so we surely will have a great presentation. Welcome, Michelle.
All right, thank you so much. Really appreciate being here today. It's great to talk to such a widespread audience across South America and the Caribbean. So thank you for inviting me. It's definitely an honor to be here. So I am in charge of the NOAA Climate Prediction Center ENSO team, and there's a team of us, there's about 10 of us usually, who put together the monthly updates. And in recent years, we have started monitoring and forecasting a index on the side called a relative Nino index. So this is a fairly new index, and I want to explain how we use it and why it is important to us. Hang on just a second. All right. So this index was developed by Gert-Jan van Oldenburg and Harry Hendon many years ago. And it has become more plainly obvious in recent years that it is important to monitor. And I'm putting this as a recent example to kind of motivate this discussion, which is this past winter, at least boreal winter, austral summer for you, when we saw tropical atmospheric anomalies over the Pacific that were stronger than the anomalies that we were seeing in the ocean, particularly the sea surface temperature anomalies. And if you look at the official NOAA metrics, which I will go into in the next slide, we officially, if you look at the historical ENSO episode table using NOAA's criteria, it was ENSO neutral. We did see a period of brief cooling. Our public guidance was was in a La Nina. We were saying there was a La Nina advisory, but when all was said and done, it did not last long enough for us to officially regard it as a La Nina, which is a bit mysterious. And it was very perplexing to see this sort of weak sea surface temperature anomalies across the Pacific, and at the same time see these strong atmospheric responses. So on the lower left there is outgoing long wave radiation, which is a proxy for rainfall and convection. And we saw a lot of drying in the central Pacific and a lot of enhanced convection over the maritime continent. That's a very clear La Nina signal. The intensity was definitely a moderate to strong intensity. And it's not just this variable. We also were looking at sea level pressures in the Southern Oscillation Index, and it was also indicating a stronger La Nina than the sea surface temperatures were implying. So why was there this offset? So to back up, if you're not familiar with the NOAA product, and keep in mind I'm at NOAA, so I'm very United States focused. And there are different indices around the world. We all have different choices. We have different thresholds. We have different durations. And I like that. I think that you should tailor ENSO to your particular location of the world. We like the Nino 3.4 index in the Nino 3.4 region, East Central Tropical Pacific, because it is strongly related to other tropical atmospheric indicators. In particular, we're interested in the full basin coupled ENSO response, which is distinctive from the coastal El Nino response that can certainly have huge impacts in parts of South America. Um, for us over the United States, we want to see that full basin coupled response because we need to impact the jet stream, and that jet stream has downstream impacts over North America. So this is a major reason why we monitor Nino 3.4. And so we monitor on weekly, monthly, and seasonal timescales. When we start averaging the seasons, that's when we start calling it the Oceanic Nino Index or the ONI. You'll hear me say ONI a lot. And all I'm talking about is Nino 3.4 with a 3-month smoother through it. And when you do that, you get this time series at the bottom. And so NOAA has a historical definition. This isn't used in real time. Real time is a little different, but historically we classify El Nino episodes when we're in excess of about half a degree for at least 5 consecutive seasons. So everything in red here fits that criteria for a historic episode. La Nina is, of course, the opposite. It's a cooling minus half degree or less for at least 5 seasons. Okay, there's a problem with this index, though, and it's become increasingly obvious in recent years, which is that the ONI, or this time series of 3-month overlapping seasonal values through the Nino 3.4, will vary depending on what climatology or base period you pick. Traditionally, because we're part of the Weather Service and NOAA, we follow the WMO guidance of updating our climatologies to these 30-year recent periods. So right now, the official climatology is 1991-2020, and this is what this historical El Nino La Nina periods look like with that more modern climatology. But say hypothetically I were to do this with a 1941 to 1970 climatology, I would get this graph instead. And it's very different from this one, right? I mean, you can just see the differences here. Clearly more and stronger El Nino events, fewer and weaker El Nino events over here. La Nina events are increasingly prominent when I use the newer climatology, and the older one, you can see it's very different. And so this is a little weird, right? Because basically what this is saying is that what you consider an El Nino La Nina event depends on your era and what you thought was normal. So why is this happening? Well, it's actually fairly obvious. The climate is changing. And we have these different 30-year climatologies. This is showing the seasonal cycle of Nino 3.4 by month through the entire calendar year. And the red lines here are the averages, the older 30-year averages, 1930s onwards. And then the blue lines are the more modern 30-year climatologies. And so clearly, depending on which climatology you pick, you may get a very different definition of your El Nino, La Nina events. So we recognized this over a decade ago. We knew this was an issue. And we decided to address it at that time with this fairly ad hoc fix. We said, okay, since we know this is changing, why don't we just use a rolling 30-year climatology? And we'll update it every 5 years. And WMO tends to update every 10 years. So we were like, let's split the difference and update it every 5 years. And so we did that. And so our official ONI is the red line here. Oh, sorry, our official ONI is the green line here. And as you track this through this time series, you can see at least the older period, you have more positive values because of this rolling climatology. And then if you were use the ONI with the more modern climatology, you would actually see more negative values. And that makes sense because this is a warmer climatology. So subsequently, the earlier part of the record becomes cooler. And these can be quite different. You can see up to about half degree, 0.6 degrees. And there is some annoying aspects to this, though. You have to keep track of all these rolling climatologies. It jumps when the climatology gets updated. And then you see this weird thing going on here in the last decade or so where there's almost no difference between them. And why is that? Well, it's because we're using a past 30-year climatology. This record, we're actually using a centered 30-year climatology. So we're using the climatology that occurred around that year. And then as we get into the more recent records, we can't center it because we don't have the future. And so this is an ideal. This is setting up a situation where the index is going to lag the changes. Now, I realize this is a little confusing. So some people like this table. And so this is showing exactly what we do for our official index. We take our anomalies calculated between different periods here. And this is the 30-year climatology that we remove from each of those periods. And you see that we're rolling it through, updating it every 5 years. And then we come to this period where we're using 1991-2020 climatology. That's our most recent climatology. And now we have to fix it because we don't have the future. We can't center it. And so this is a little weird. This means our ONI table up through 2010 is this fixed centered climatology, but the most recent decade is using a lagged climatology. So the values that we have as for El Nino, La Nina are a bit apples to oranges, right? We're not really comparing the same type of strategy. And this can get kind of interesting because here is the last winter. This is our big table that we have on our website. And you can see that we hit our thresholds for La Nina for 2 seasons, but we didn't quite make it for the 5 seasons. So at least when you look at this table right now, it's classified as ENSO neutral. However, I strongly suspect that will change because I expect that it will continue to warm. And so when we eventually create the climatology that will be used to decide whether this period is a La Nina or not, it will be 2036 and we'll be using this climatology, which will probably be warmer than the 1991-2020 that we're using now. So weirdly, if we're around till 2036, we may actually see this past winter become a La Nina later on. So we know this is a problem, and that's why we were very interested in this relative ONI or RONI, which is essentially a new index that we're using and tracking, and we especially like it for real-time use because of the problems I just mentioned. So a red line here is the traditional ONI. So this is our official operational one at NOAA. And the blue one is the relative ONI or RONI. And you can see they track each other to some extent, but there's some important differences, especially in the real-time record. Again, when we're starting to use these lagged 30-year climatologies, that's when these big differences start emerging. And these can be quite distinct. In fact, since late 2023, we've had about 0.4 to 0.6 degrees differences constantly. All right, our thresholds for ENSO are half a degree. So these are tremendous, and these are big differences that can change whether we consider it neutral La Nina or not. So this is something that's, I think, increasingly important to consider. All right, these two plots are the exact same as I showed you earlier. This is using the warmer 1991-2020 climatology. This is using the cooler 1941-1970 climatology. Again, look at those big differences. So now I'm going to do the same plot, but I'm going to use the RONI. So these plots I'm using in 1991-2020 climatology. These plots I'm using in 1941-1970 climatology. And one aspect of the RONI, the relative oceanic index, that we really appreciate is that the historical El Nino definitions and La Nina definitions do not change as dramatically as they do for the traditional index. So it's much more stable when we use this strategy for computing our El Nino, La Nina episodes. In fact, you can see this past winter right here, if we were using RONI officially, it would have been considered a La Nina. ONI, of course, did not qualify for a La Nina. All right, at this point, you're like, okay, this is really interesting, but what is RONI? How do you calculate this? It's a really simple calculation, which is an attractive aspect of this. Basically, you take Nino 3.4 index, which is shown here. You compute it as you normally would. It's 30-year climatology, and you calculate it. And then what we do is we take the tropical mean sea surface temperature index. This is 20 north, 20 south, and we calculate that. We also remove a climatology. And then we take these two and we subtract them. That's all we're doing. We're just subtracting these two indices, and then you get to the one at the bottom. Now, when you subtract these two indices, you do lose some variance, which means your thresholds will change, and we didn't like that, so we rescale it. And the rescaling is just this variance adjustment, standard deviation, the ONI, and the standard deviation of the ONI, basically the difference between these two indices. I have some links at the end of the slides, so if this doesn't make sense to you, I have code. It's Python code. And I'm going to show you those links at the end of this presentation, and you can look at that code and calculate it yourself. And so one of the reasons this works is because in the tropics, we have low Coriolis. And so there's a very intimate relationship between local sea surface temperatures and convection and rainfall. This really only works in the tropics, this relative method. And what we find, and this is past work by, at least a dozen others, that we find that in the tropics, the local SSTs, in the difference between that and the tropical mean SSTs is really where you get this instability and rainfall and this convection. So that's all we're trying to identify here. We're just trying to say what is the optimal combination so we can see that coupled response in ENSO. Okay, so as I pointed out, and this is showing weekly averages, on top is just traditional anomalies, and the bottom is the relative anomalies. I'm doing it at each grid point here, so I'm not doing it just for the Nino 3.4 region. Nino 3.4 region is the black box. And you can see this past winter, we had much stronger, cooler values in the relative index than the traditional. And there's another perspective on this, is these evolution plots. And here I'm plotting monthly values of Nino 3.4, the traditional method. And then at the bottom is the relative method. And this is just showing the black here, the past year. So this goes up to May 2025, and this starts in January 2024. And so this is what the traditional Nino 3.4 value did over time. Here's our thresholds for La Nina. And you see you spent a couple months in La Nina territory, but it was really on the kind of the weaker fringe So all these other lines, these are other past La Niñas, all right, in our historical record going back to 1950. And what you see is relative to those past La Niñas, we were really at borderline weak event. But when you look at a relative index, a very different story emerges, all right? Here, now it looks more like a moderate strength event, and it is very comparable to moderate strength events. So this is an issue, and it's something that we all have to concern ourselves with. So recently, this is just this past winter, or sorry, boreal winter, austral summer. We saw these strong responses in these atmospheric indices like the equatorial SOI, very positive values indicating an energized Walker circulation. We also saw very positive values in our Central Pacific OR index, which is a measure of convection in that region, also on the stronger side of all these different past La Niñas. So the atmospheric indices were very much indicating a La Niña event. It was the SST and the traditional index that was not. So again, we monitor SST indices for a variety of reasons. Traditionally, these SST indices have high quality data sets. They're fairly easy to use. There's a lot of development, and they're important, but they're only important insofar as they reflect other aspects of the coupled system. And if they're not doing that, then we have an issue on our hands. All right, so this just summarizes everything. I've pretty much gone through the meat of the talk. Um, Here are some reasons I think that people should consider at least starting to monitor and potentially predict relative index on the side. One is I like that it's very similar to the traditional Nino 3.4 index. I showed that here. I mean, your users, you would use the relative index the exact same way that they use the traditional. There's not a lot of surprises here. This is not a totally different index with different statistics. So I like it because it's a do no harm philosophy. And relative index is more stable. You can pick any climatology you want, and you will define the same El Nino La Nina events through the record for the most part. So I think that's very attractive. Third is it's fairly simple index. I mean, you calculate your standard Nino through report, you subtract off the tropical mean, you do a little adjustment for the thresholding. There's not a whole lot of statistical choices here. I didn't get a chance to talk about it. I just don't have time. We looked at the forecast skill. It's very comparable. The relative and traditional are about the same. In fact, I think there's evidence in the last decade that the relative forecasts have had smaller errors than the traditional. So I think the models are predicting relative indices a little better. And then lastly, we are starting to see these big differences between the relative and traditional. And that's the most concerning part to me, is that I want to make sure that we're capturing the entire ENSO system, and it's clear that these questions around our climatology are increasingly a problem. So there's a couple papers, John von Oldenburg and Harry Hendon really came up with this idea. We adapted it, we modified it a little bit. We modified the scaling procedure in particular. We thought it was the method used here was a little unwieldy. It was a little hard to calculate a model. So we did kind of look at it from more operational framework in the second paper. And this was done with my colleagues at the Bureau of Meteorology in Australia. They are also big proponents of the relative SST index. And so that wraps up my talk. I have a whole bunch of links here. So if that was too short and you want to learn more, we have our indices online. You click them and you get the values. If you want to calculate the indices yourself, there's a GitHub here. It directs you some Python code, and you can do it there. I really want to thank Ken Takahashi, who I know wasn't able to make it on this call today, but he approached me back in late 2024 and said it'd be great if you wrote an explainer on relative SSTs, and we'll translate it into Spanish. And so that's available. And then there's also a YouTube here where I talk about this for 40 minutes. So this is 15, but if you want to hear more about it, you can go to that. All right, and that wraps things up for me. Thank you so much for having me here today.
Thank you very much, Michelle, for your excellent presentation. There are many questions in the Zoom platform now, so I hope we can help with the translation in order you can respond online.
Yeah, that would be
Now,
great. I'll go ahead and respond on the side if it's translated into English.
Okay, excellent. Y ahora damos la bienvenida a la doctora Marisol.
And now
Osman
we
del
welcome
Departamento de
Dr.
Ciencias
Marisol
de la Atmósfera
Osman
y los
from the
Océanos de la
Science
Universidad de Buenos
Department
Aires
of the
para que nos converse sobre el
Atmosphere
impacto
and
de la
Oceans
variabilidad del Océano
Department of the
Índico en
University
la
of Buenos
Sudamericana.
Aires to
Y
tell us
la
about
pregunta que le
the
hacemos
South American
cómo
climate
debe
and
incluirse el Océano Índico en
the
estas
Indian
previsiones. Marisol,
Ocean and
bienvenida.
how it can be
Muchas gracias,
included
Rodney.
in our
Gracias a
predictions.
Pedro y al IAI
Welcome,
por la
Marisol.
invitación a
Thank
participar.
you,
Entonces,
Rodney,
voy a
thank you, the
presentar
II,
algunos
for having
resultados
me.
y quiero dar crédito
And
a
I
mi
will
estudiante,
present
Luciano
some
Andrián, que está haciendo
results,
el
and I want
tesis de
to credit
doctorado
my
en este
student,
tema,
Luciano
tratar de
Andrián, who
mirar
is
El
working on
Niño
his
en combinación
dissertation
con
on
otros
this,
modos de
on looking
variabilidad. En
at
este
El
caso,
Niño
voy a presentar algunos
next
resultados
to other
relacionados con el
models
dipolo del
of
Océano Índico y la
variability
variabilidad
with the
en esa
Indian,
cuenca.
such as the Indian
Entonces,
Ocean in this
solo
case. And
para poner un poco
so,
de contexto, muchos de ustedes
just
conocen cuál
to
es la
bring some
teleconexión y los
context. Many of you
impactos más
know about
comunes
the
del ENSO en
interconnectedness
Sudamérica, que fue lo que
and the most
nuestro
common
trabajo nosotros
impacts of
vivimos.
El Niño in South
Ustedes han
America, where
visto
I work,
el
where
Pacific
many of
South
us
American
live.
Pattern
You have
en el
seen the Pacific
geopotencial que
South
está
American
mostrando en la
pattern in
figura
the
de la
geopotential that I'm
izquierda, y es
showing
típico
in on the
cuando
left.
tenemos
It's the
un evento
typical
El
for
Niño
when we have an
y los
El Niño
impactos en la
event
lluvia con
and
anomalías
the
negativas en
impacts
el norte de
of
Sudamérica
rainfall
y
with
positivas
a
en el
negative
sureste de
impact on the
Sudamérica
north
y
and
en
positive
Chile,
in
y
the
también sus
south
impactos en la
of South
temperatura,
America and
más
Chile,
frío
with
en la
impacts
Patagonia
on
y más
temperature.
cálido
It
sobre
gets
todo en la
colder
costa
in
adyacente, donde se da
Patagonia
el
and
calentamiento
warmer
típico
in the
de
coast,
un evento
where we have the
El
typical
Niño.
warming
Esto
up
fue muy
of an
documentado
El
en
Niño
muchos
event.
trabajos.
This has
Y a
been
nosotros nos
documented
interesaba
in many,
entonces empezar a
many
mirar
papers.
qué pasaba con
And
lo que
what we
podemos llamar
wanted to
un
do
hermano
was
menor
to
de El
look at
Niño,
what happens
que
with
es el
perhaps a
dipolo del Océano
younger
Índico.
brother
Para
of El
quienes no han
Niño, which
escuchado
is
hablar de él, es un
the
modo de
Indian
variabilidad que
Ocean
ocurre
dipole,
en el
which is
Océano
a
Índico y también está
variability
caracterizado por
model from the Indian
anomalías de
Ocean
signo opuesto en el
with opposite
Océano Índico
sign
Oriental y
variations
Occidental,
in
¿no? Y en
the
esta figura
Eastern
del
and
Bureau of
Western
Meteorology, que lo
Indian
muestra en su
Ocean.
fase
We have this
dispositiva, ¿no? Con este
chart from
encreventamiento del
the
océano más cerca de la
Bureau
costa
of
africana,
Meteorology, and
un
we have
enfriamiento en relación al continente
warming up
antártico.
next to the African
¿Y por qué
coast
nos interesa
and
empezar a mirar
cooling
qué pasa
down
con
in
el
the
Océano
in the
Índico?
opposite ends.
No solo porque
And
la
so why did we
variabilidad
want to
en el
look at
océano
this?
tropical puede
Because the
generar
variability
teleconexiones
in the
que afecten a zonas
tropical
remotas como Sudamérica,
ocean
sino que
may
también, y es una
cause
pregunta también abierta si el
teleconnections
cambio
that
climático
affect
está haciendo
the
esto o no,
southern part of
hemos
South
observado en el
America.
periodo más
And
reciente
we
una
have
ocurrencia
observed in
más
the
seguida
most
de
recent
eventos de este dipolo
periods
del Océano
a
Índico.
higher
Y
frequency of
entonces nos
this phenomena.
preguntamos si esto ha
And so
tenido
we
algún
wondered
impacto en
whether
cómo la
this
teleconexión
had
del
had
niño se
any
desarrolla.
impact on how the El
Entonces,
Niño teleconnection
Luciano se puso a
happens.
mirar primero
And
qué
so
pasaba con esa
Luciano
teleconexión,
looked
analizando en
at
el
what
registro
happened
histórico
with that
los
connection,
eventos El
looking at
Niño y
the
La Niña que
historic
ocurrieron
records of El
sin que
Niño and La
ocurriera un
Niña
evento
that
del dipolo del
happened
Océano Índico, y
without
es lo que
having
muestro en
an
el panel
IOD,
superior
an Indian
en esta
Ocean
figura.
dipole, which
También
is
miró
what I
los
show
eventos
in
del
this
dipolo del
chart.
Océano Índico,
He also
tanto en su fase
looked
positiva
at
y negativa,
Indian
en
Ocean
ausencia
dipole,
de
both in the
eventos
negative and
El
positive
Niño,
phase, in
y
the
miró qué
absence of El
pasaba
Niño
cuando
events.
sucedían en
And he
simultáneo.
also looked
¿Y
at
por
what
qué
happened
esto? Porque
when they
sabemos
happened
que a
simultaneously.
partir de otros
And
estudios que
why? Because
en
we know
nuestra
from other
primavera, ¿no? La
studies
primavera
that during
austral,
our spring,
el
the
dipolo del
southern
Océano
spring,
Índico
the
tiene un
Indian
máximo.
Ocean dipole
También
has a
sabemos que la
maximum.
variabilidad del Niño
We also
impacta
know
muy
that the
fuertemente en
variability of El
Sudamérica y que
Nino
estos dos eventos
has a big
pueden
impact in South
ocurrir de
America,
manera
and these
simultánea,
events can happen
siendo más común la
simultaneously
ocurrencia de un evento El Niño al mismo
with
tiempo que un evento del Océano
it's being
Índico
more common to
positivo
have El
y un evento La
Niño
Niña con
and
eventos del Océano Índico
an
negativos. Entonces, él
IOD
se
that
puso
is
a mirar
positive and La
cómo eran las
Niña with an
teleconexiones
IOD that is
en
negative.
estos casos.
And so he looked at the
Lo que
connections.
notamos es que
And what we observed is that when El Niño happens in combination with a positive IOD, we are having a much stronger teleconnections in the wave trains. I don't know if you can see in the screen that I'm with the arrow I'm pointing where the current that leaves from the Indian Ocean then becomes stronger as opposed to when these events happen separately. And when we look at what happens with La Niña and the negative Indian Ocean dipoles, we don't see that signal being reinforced. At the same time, I put between parentheses the number of cases we found in the historic records. And we see that there are few cases in order to have some robust conclusions drawn. And so, on the other hand, when we look at the distribution or the intensity of the events of El Niño and the dipole events, we have a scatter plot with the IOD in the horizontal axis and El Niño in the vertical one. And we see that there are a lot more cases of those simultaneously El Niño and dipole, whereas La Niña and negative dipoles are fewer. And so we may wonder whether this asymmetry in the events studied could have an impact on the intensity of teleconnections and the impacts that we will find in South America. And so what we did was take the CFS V2 model, the version 2 from NOAA, which is very used for weather predictions. And we used the hindcasts for different months to go through September, October, and November, and we found 3,744 realizations of these events that may be negative IOD and La Niña, or positive IOD and El Niño, and we gathered more cases using a model, and we tried to explore whether with a lot more cases we could, combining these impacts of the Indian Ocean dipole and El Niño. Then we divided the cases by intensity and severity of the event. When it was 0.5 with one standard deviation, and strong when it was higher than one strong deviation. So we started characterizing them by moderate IOD, positive IOD, combined with strong El Niño or moderate El Niño, or cases where there was only IOD. We also included a strong positive IOD and moderate or strong El Niño and La Niña, and looking at the differences represented by geopotential. And what we found was that in general, when you have a moderate or strong event of the negative phase of the IOD, it doesn't seem that it's a moderate La Niña. We see not many interconnectedness, but when we look at moderate El Niño, we see that they are stronger if they happen at the same time as moderate or strong IODs. But when we have a strong La Niña that can happen with a strong negative IOD, that will amplify the teleconnections. And we see also that in all cases, whether happening with moderate IODs or strong IODs.
cómo eso podía impactar en la predictibilidad, porque uno podría estar teniendo un cambio en la anomalía que está teniendo, pero
We
también
might
mucha
see a
dispersión de
change
los
in the
casos.
anomaly, but
Y en realidad lo que
also
estamos
great
viendo después,
case
cuando estudiamos la
dispersal.
señal
So
versus el
when we
ruido
studied
para
the
estos mismos
signal and
casos,
the noise
vemos
for
que en
these
general cuando
cases,
ocurre
we
un
see
IOD muy
that when there
intenso
is a
es
very
cuando tenemos
intense,
además
a very
un
strong
aumento en la predictibilidad
IOD
porque
is when
vemos
there
que
is
la
an
señal
there
versus
is
el ruido
increased
en las
predictability
teleconexiones también
because signal to
aumentan
noise
en
ratio
casos de tanto
increases in
El Niños
teleconnections
fuertes y moderados
for a
como
strong
las
and moderate
niñas
El Nino
fuertes.
and
No
strong La
analizamos
Nina.
los casos en donde la
We do not
niña ocurre
analyze
con
the
eventos
cases where La
positivos de
Nina
IOD porque en el modelo
has
también
strong
encontramos pocos
IOD
casos, un
positive
10%
events,
respecto de lo que
because in the model
consideramos
there are
casos
few
neutros.
cases, 10% compared to
Pero bueno,
neutral
después nos
cases.
enfocamos en lo que podía
But
verse
then we
en los
focused on what
impactos
we saw
en
in
Sudamérica. Y en
the
este caso yo directamente
impact
voy a
in South
mostrarles algunas
America. I would
composiciones
like to
utilizando el
tell you
modelo
a few
SFS porque
compositions
encontramos
using
que
the
también es bueno para representar la
CIIFES
respuesta
module
al
because
niño y
it's
al
also
IOD
useful
respecto de
for
lo que vimos
representing response
en las
to El Nino
observaciones
and
y me interesa
IOD
particularmente
regarding the
enfocarme en el caso
observations.
de
I would
cuando
like to
El Niño
focus
ocurre con un
on
evento
the following
IOD
case when there is
positivo al mismo
an El
tiempo.
Nino event with
Entonces,
an
en la izquierda
IOD
les muestro
positive
las
event at the same
composiciones de los
time.
campos de
Have a
precipitación,
look at the
tomando El Niño
composites of the
por separado,
precipitation
tomando eventos
fields.
IOD por
El Nino,
separado y cuando ocurren en
IOD
combinación.
events, and
Entonces,
both
vemos
together.
cómo
We
se
see
combinan
how
linealmente las señales en los dos
the
casos
signals
y cuando ocurren
combine in a linear
simultáneo, si uno
way in
superposiona los
both
dos paneles,
cases.
obtiene algo muy
And if we
similar
were to
con
overlap
síntomas
both
de
panels, we
esos
will have
casos
something
efectivamente. Entonces,
similar to
hay una
what would happen
combinación
in each case. Therefore,
que
there
en
is
algunas zonas va a
a
actuar
combination, and in some
destructivamente porque las
areas there will
anomalías
be
tienen
destruction because the
significados. Esto
anomalies have
sucede alrededor de
opposing
los 20 grados
signals,
sur, por
and that
ejemplo,
happens
pero pueden
around
actuar
20 degrees
constructivamente si
south,
las
for instance,
anomalías
and they can be
coinciden
constructive if the
en el signo, como
anomalies
puede ser el caso
have
del
the
norte
same
de
sign, for
Sudamérica.
instance, in the
Y
north
ahí
of
estamos
South
viendo la
America.
señal
And that's
más
where we
importante
see the
en donde
main
el
signal,
polo del océano
where
Índico puede estar
the
alterando
IOD
el
might
efecto que
be
El Niño
affecting
suele
the
tener
factor
en
of the
términos de
usual
impacto
effect
en
of El
Sudamérica.
Nino
Mientras
regarding
que en la
its
fase
impact in
negativa,
South America.
utilizando tanto observaciones como utilizando el
Whereas
modelo y
when
analizando
we use
diferentes
the
métodos,
model
no estamos
and
viendo
apply different
algo similar.
methods, we do not see
Y me gustaría
something
cerrar con un ejercicio
similar
que
with
hicimos
the
porque
negative
uno podría
phase.
preguntarse muchas
I would
veces el
like to show
pronóstico, ¿no? Lo
you the
presentamos
following
como
exercise
chances, ¿no?
because many
de
times
ocurrencia de un evento
it's not
dividiendo en perciles
about
de la distribución o presentándolo como
predictability or
apartamientos
possibility of
respecto de
an
la
event,
climatología.
or
Entonces
sometimes
el
we
ejercicio que
present
hicimos
this
fue
as
para
something
distintas regiones
other
de
than
Sudamérica
climatology. So for
analizar a
different
partir
regions in
del
South
modelo
America,
cuál es la
we
distribución,
analyze from the model
¿no?
which is
De densidad de probabilidad climatológica,
the
¿no? Que es la que se representa en
climatological
esta línea negra en
um,
este gráfico. Y también miramos
PDF.
cómo cambia esa
And this is
distribución de
shown in the graph.
probabilidad
And we also
según
see how
tenemos
that
cada uno de los
probability
eventos, el
distribution
niño, la
function
niña o el
changes
IOD, y cómo
depending on
cambia
the
de manera combinada,
Nino
¿no?
IOD
Siendo que
events
esto
and how
representado
this
en este caso
changes
por
in
esta línea
a combined
roja para un
way.
evento en
And this
particular.
might be
Entonces
shown, this is
calculamos ese
expressed by this red
apartamiento
line.
en la
So we
distribución de densidad de
calculated
probabilidad
the difference
y es lo que muestro
in
en este
the
mapa de calor
PDF, and
para
this
la
is what
precipitación y para
we
la temperatura. Entonces
can
uno
see in
puede
this table
identificar
for
para ciertas
precipitation
regiones de
and
Sudamérica
temperature. So for
cómo
some
es ese
regions
cambio
in
y
South
cuál es la intensidad de
America,
ese cambio
we can
representada ahora
detect the change and
en
how
términos de
intense
esta
or strong
función
the
de
change
distribución de
is
probabilidades. Y en particular
according to
se ve
this
bastante claro, a
probability
modo de ejemplo,
distribution
voy a
function,
demostrar cómo
PDF.
en el
Just by way
noreste
of
de
example,
Sudamérica, del
what
este de
I would like to
Argentina
show
y
you
sur de
how
Uruguay, cuando
Uruguay,
uno tiene, en el caso
Argentina,
de los eventos El
and
Niño,
southeast
un
of Argentina,
apartamiento
when
en
you
el
have El Nino
0,34 o
event, and there
0,37
is
en
a
la PDF respecto
difference
de la
of
climatología, cómo eso
0.37 or
aumenta
34
cuando
regarding
uno tiene
PDF and
un evento El
climatology,
Niño
that increases when there is an El
ocurriendo
Nino
junto
event
un evento
occurring
del
at the
IOD
same time
positivo. Y
as a
conclusiones
positive
similares
IOD
pueden
event.
sacarse en términos de la
Similar
temperatura
conclusions
y
can
también
be
con
drawn
anomalías
regarding
negativas de
temperature
precipitación
and negative
para otras
precipitation
regiones
anomalies
de
for
Sudamérica también.
other South
Por eso nos
American
parece
regions. This
importante
is why
considerar a
it's
la hora de estar
important to
analizando la ocurrencia
do the following. When we analyze the occurrence of an El Niño or La Niña event, I need to be able to see if it is co-occurring with other events. In the case of the IOD, it's very interesting to consider this during our spring because they can modulate this teleconnection that we know very well. And many times it intensifies the anomaly, and sometimes it reduces the difference with climatology. I would like to close by saying once again that usually the most solid results have to do with El Niño taking place together with positive IOD events. And in particular, the stronger the dipole, the stronger its influence, as you can see in El Niño and its impacts in South America. So that's the end of my 15 minutes, and I'm open to answering any questions you might have. Thank you.
Gracias, Marisol.
Thank you so much, Marisol, for this excellent presentation. And the questions can be found on Zoom, and they will be answered later on. Now we would like to invite Dr. Pedro DiNezio from the University of Colorado, Boulder. He will be talking about asymmetries in El Niño and La Niña forecasting. Is La Niña easier to forecast than El Niño? That's a major question for our operations community and audience. Welcome, Pedro.
Gracias, Ronnie. Ahí está. Perfecto.
Thank you, Rodney. Great.
Bueno, yo quería hablar un poco de
Thank you.
es tan fácil
I would like to maybe talk about how it's easy or difficult to forecast El Niño. It's so difficult to forecast El Niño compared to La Niña. I'm Argentinian from the agricultural areas in Argentina, and in my family, everyone knows that after El Niño, there's La Niña. But what's difficult to do is to say when the El Niño is coming. I'm sure that many people in this audience have had problems with this. And this, sorry, we can't see your presentation, Pedro. Can you please fix that?
Vemos el fondo de tu pantalla como unos árboles, pero no vemos el PowerPoint.
Uy, qué lástima.
Yes, sorry, just a second.
Gracias, Ana.
Thank you, Ana.
¿Quieren seguir con la próxima presentación mientras yo me organizo?
Let me just get organized. Maybe we can go on to the next presentation because I'm having some trouble with my presentation. No worries, Pedro. Until you can sort this out, let's invite Dr. Cristian Martinez-Villalobos from the University, Adolfo, Ibáñez, Chile. He will be talking about challenges in understanding and forecasting the coastal El Niños, and he will tell us when and where the coastal El Niño matters the most. Welcome, Cristian. You have the floor. Thank you so much. Can you see my presentation? Yes. Okay, great. Thank you for your invitation. I'm so happy to be here in this event. I prepared the presentation in English, so if you get some Spanglish, I'm so sorry. As Rodney said, we would like to talk about these coastal El Niño events. I would like to talk about how they work, how they feed within the diversity of El Niño events we have. I will be addressing some challenges we have as well. And if we have time, I would like to talk about why it's challenging to predict this type of event. Thank you to my collaborators. Here, Boris DeWitt, René Garrod, and Leandra Loyola. This would have been impossible without them. First of all, this shows us the clouds associated with tropical semi-organized cyclone Yaco 2023 in March. This is a very rare event or cyclone in Peru because our water is so cold. I'm not saying that this was a very much organized tropical cyclone, but it was semi-organized. Here we can see some of the consequences of the 2023 El Niño event. At the beginning of 2023, we had a coastal El Niño event with the coast of Peru increases temperature north of Chile as well. And this tropical, semi-organized tropical cyclone caused many floods. There were people who died, who lost their homes, and there were harms that can be valued in millions of dollars. This is a 2017 coastal El Niño event, similar to the 2023 event, which also caused floods in some parts of Peru. It rained more than 15 times the usual precipitation levels in this area. This created a huge problem in Ecuador as well. Before this, 2017 and 2023 coastal events, coastal El Niño events, we didn't talk about this as well. So this is a relatively new topic, in particular within the international community. Let's see what happened with the surface temperature anomalies. These are the ones associated with the 2017 event between February, March, and April. There's this generalized heating, in particular in the South American coast, but there wasn't a Central Pacific event. Typically, when this area heats up, this is usually an El Niño event, but this event was different because only this area increases temperature. The Central Pacific was neutral. And there was a strong anomaly in the Niño +2 area. Some context. Let's have a look at the charts for 1983, 1998, February and April as well. This is the phase where the events were decreasing, the super El Niño events. And we can also see both the anomalies related to the events, a huge representation in this area as well. But this event is not the same as this other one. Here we have El Niño as we know it. But this in 2017, we had rising temperatures only in the coast. So this type of anomaly is different. First, I would like to define what an El Niño event is. I would like to define what the coastal El Niño event is, where the coast heats up, but not the rest of the Pacific. But before saying that, let us now talk about the precipitation climatology in Niño 1+2 region and surroundings. And this has to do with the stational movement of the intertropical convergence zone. We have a clear seasonal cycle. Basically, precipitation tends to increase in the El Niño 1+2 region at the beginning of the year. The sea temperature is quite low, so any increase in temperature in other seasons leads to large precipitation levels. And here we can see the connection between precipitation and absolute surface temperature in the last 40 years, 1980, 2020. The higher the absolute temperature, the higher the response to precipitation levels. This happened in 1983 and 1998 when these super El Niño events were decreasing. But the third year with the highest precipitation levels was 2017. We don't have 2023 here, but it was something similar. Something we should say in the Super El Nino 2015-2016, this was a Godzilla El Nino, and the precipitation response was much lower. So these are important data. These events were El Nino events, and these were coastal events. What I'm showing you here are 3 coastal events and also 3 coastal Niña events. And they usually have less precipitation than normal. So this can also have an impact. So the title of my talk, where and when do coastal Niño and Niña matter most? Usually at the beginning of the year, March, April. They can take place at any time during the year. But that's usually the date, February, March, and April. Why? Because when temperature increases at that time, there is increased precipitation as well. Where in particular in Peru and Ecuador, there's a direct connection with rains, floods, social problems. There is also a connection with dengue, etc. If we go to the south, we can see an increase in the temperature of the Chilean coast associated with these coastal niños. But the damage here is more ecological, not so much regarding floods. There is a study that links this coastal niño and the wildfire season in Chile, for instance. Okay, so what's the main challenge or question? How do coastal El Niño, La Niña events fit given the observed ENSO diversity? So, first of all, the El Niño events in general can be classified as Eastern Pacific EP or Central Pacific events CP. And they are classified according to the temperature anomaly peak. For instance, we have a composite of EP events and CP events. So the question is, where do these coastal El Niño La Niña events fit within this ENSO diversity? To determine this, first we need to classify these coastal events. I will be interested in coastal niños, where the Eastern Pacific heats up, but not necessarily the whole basin. So I'm distinguishing the coastal children associated to El Niño events and the coastal niños, where the coast heats up, but not necessarily the rest of the Pacific. So, coastal events, we use Niño 1+2 indexes, and the coastal El Niño also measuring the Central Pacific. With the 2 indices, I measure the rising temperature in the coast, but not in the center. And the same for coastal niñas. Here you have more information about this definition in this paper. We don't always define coastal El Niño following the same definition. That's why it's important to see this. These coastal El Niños are usually present usually in 2 varieties. One is ENSO-like, they're more typical, but the other are more dipole-like. And we will be addressing this further later on. Since 1980 and 2017, we have 7 coastal El Niño events, 3 coastal Niño, including the 2017 one. And many people prepare a cluster about showing where these events fall within this El Niño diversity. And we can do this by implementing this phase space. What does it show us? The first main component of surface temperature anomaly in the sea in this direction, and the other one in the other direction. What is important here is that to classify this diversity, we need to create two indices, and here we have two indices. These can be rotated, and we can see the direction of the type of EP events this way, and the Central Pacific events in the other way.
So February, March, April, we have these phase 83, 97. We see these that can be located here, and those are the EP Super El Niño. Then 2015, 2016, you cannot see those as clearly because it has, and it's not here, because it has mixed characteristics. And so in this coastal El Niño, we have these events, these three in red, and these ones in blue. And what we find is that those live in this direction. So they're not Eastern Basin El Niño or Central Pacific. They basically live in this direction. So it has a lot to do with what the second component of the anomalies does. And in the main component, the expression is low. And so how do these coastal El Niño fit in the diversity of observed El Niño phenomena? Well, they don't fit traditionally. They live in this direction. The diversity of coastal events has to do with what the second component is doing. And so how can we visualize these events? I mentioned that we have two types of event in general, ENSO-like and dipole-like or type 2 events. And basically ENSO-like events are those in which the entire basin warms up or cools down, with a peak in the Eastern Pacific, in the tropical part. However, these events cannot be cataloged as a basin event because it's a mild warming up or cooling down. And the ones that are, how can I say it? The ones that are the most extreme are the dipole-like ones. Basically, they are characterized by an increase in surface temperatures throughout the area and a decrease in this area, and vice versa for the coastal and middle areas. I don't want to go too much in depth, but what I would like to mention about this dipole-like event is that they have the least connection to the regular basin-like events. They have to do with these Northern Pacific or Southern Pacific meridional modes. They're more thermodynamical. They depend of the evaporation from the west feedback. And this chart shows a composite of a nonlinear reverse model. We don't have too many events in the historic records in order to increase the number of cases, we use these techniques. And so in this integration, we can see how these variability modes affect the evolution of these coastal events. So basically, this is an analysis of this long integration and how it evolves in the coastal El Niño type 2. We have 0 here, note that, and how each of these indices evolve. And so what we can conclude is that coastal El Niño is generated in parallel to the Pacific meridional modes, and supercoastal El Niño has a contribution from the Southern Pacific meridional mode in this phase. So that's what just what I wanted to mention about this dynamic. And I only have a few slides left, but we discussed the impact of these phenomena, and we can see, we can describe them on what they look like, what the dynamic is, and how they fit within the diversity. But the next challenge would be that these coastal El Niño are not included in global. So this is what would look typical dipole, El Niño and La Niña in observations. This is what I discussed, the linear inverse model. These are some benchmarks. These are good models. And this is what the CMI P6 multimodal mean simulates them. And we can say they are okay-ish. In general, it's not the worst that they're at, but they generate the heating where it needs to be and the cooling where it needs to be, but there is room for improvement in general. But I have seen other models that are worse, so this is okay in general. But if we go a little bit more in depth, we can ask, how do global models model the interaction between surface temperature and precipitation in this area? And I have the seasonal cycle for El Niño 1+2 with a combination of models. One thing that it's important to know is that in the y-axis, we have 5 and we have 10 in the scale. So what we can see is that the models tend to show a lot more rainfall than what it actually happens. And that is a big challenge. And where does that come from? Well, from the fact that models simulate higher surface temperatures. And so that's how that happens. There are many things that models in general don't do very well, and we have a paper about that. But something else they don't do well is simulate the frequency, because these events are rare, but they're not that rare. In observations, for example, here we have the frequency as a percentage of all months. When we have an ENSO-like coastal El Niño and an ENSO-like coastal El Niño in observations, and the same for La Niña for the dipole-like events. And so we can see there's asymmetry. There are less coastal El Niño than coastal La Niña. I'm not going to go into detail. These are the inverse models that do well, especially in comparison with the CMI P6. For many have simulate the same amount for El Niño and La Niña, but the worst part is that they simulate fewer than they actually happen. They only have 2 or 3. And in closing, let's go to the final challenge, is that these coastal El Niños seem to be less predictable than basin-wide events, even though we have had some false positives. Very well-known cases where we ended up having La Niña and the models said it was El Niño. But in some cases, under certain circumstances, we can have predictability for a year, let's say, expected for this basin-wide events. But here we have what was observed as anomalies in precipitation in rainfall in 2007. in 2023, and these are different predictions from the North American multi-level ensemble from January, from February, and we have the peak rainfall in 2007, and we can see that that peak in the predictions that started in January kind of appear there. The ones that started in February were kind of closer if you have a more tolerance even for the difference. Whereas for the 2023, we see that the ensemble model actually did worse. So in general, we can see that rainfall, which is probably the most significant part of these events, can be predictable, but we cannot expect more than 2 months, at least for now. And so I leave you with my conclusions. I think I went over time. You can see the conclusions. I'm not going to go into them, but a lot of what I mentioned is in this paper that you can access with the QR code. And I'm happy, of course, to answer any questions that you may have. Thank you so much.
Muchísimas gracias, Cristian. Muy valiosa.
Thank you so much, Cristian, for your great presentation with more sub-regional context about this phenomena from the Pacific and El Niño. And now, Pedro, you can give us your presentation. Okay, let's try again. I had to restart my computer. Can you see it now? Yes.
Perfecto, muy bien. Bueno, yo les quería hablar.
Great. Well, I wanted to discuss why is it so hard to predict El Niño and La Niña. As many of us know, after El Niño, we have La Niña. We had El Niño in 2023. In 2024, we had La Niña, even though it was hard to detect it, as Michelle explained, a bit because of the global warming pattern that confounds the levels used to determine whether we are in La Niña or not. And there was a lot of debate on whether we had gone over 0.5 or not, but it has been confirmed. So that happens in general, but why is it so difficult to predict when El Niño comes? And there's a bit of an idea that this works as a pendulum. Because we have the word oscillation in the name of ENSO, then you may think that it's like a pendulum oscillating from a warm and cold phase, but oscillation comes from a spatial pattern from the southern oscillation doesn't have to do with time, but with space. And so I wanted to clarify this. This is not a recent paper, and it's a confirmation through observation of how these changes between the cold phase and the warm phase happens, and how that is mediated through the ocean thermocline. And you can see the event in 83, in 97, in the solid black line. And as we can see, the anomalous depth of the thermocline in the dotted line precedes by several months, almost a year, the occurrence of El Niño and La Niña. When we have a positive value, we have El Niño, and then when the value is negative, we have La Niña. And this is what in the 80s and 90s perhaps made us all too trusting of the fact that this system oscillates perfectly between the two states. So after El Niño, we have La Niña, mediated by these fluctuations in the thermocline. And one follows the other consistently. And the scientific community believed that predicting El Niño and La Niña was going to be easy. But if we move forward in time, this is a paper from 2019 where we have more predictors of El Niño, La Niña, especially for El Niño. So in red, we have El Niño 3.4. We're all familiar with that index, and the time spectrum also includes El Niño of 2015, that is here in the end in red. And this El Niño from 2015 actually taught us a lot. Everyone in 2014 with the fluctuations in the atmosphere and the westerly wind bursts that in 2014 we had many fluctuations from these wind bursts, these variations in the winds that sort of predict an El Niño. And so the bars show the accumulation of fluctuations in these winds, in the trade winds. And so if you believe this predictor, in 83, we had the El Niño, in 83, in 97, the occurrence of those El Niño events was preceded by these high frequency fluctuations in these trade winds, and also by an accentuation of the thermocline. And so the conditions were there for this perfect El Niño events. And in 2014, before 2015, there was a lot of fluctuation, but we didn't have an El Niño afterwards. And so I was already in this world there. I was a postdoc in Boulder, and I remember debating a lot with people from NCAR. We are having an El Niño. It was even in the news. I don't know if anyone remembers, but in February and March of 2014, we had these fluctuations, and there was a lot of energy built up that could have produced an El Niño, but then they stopped happening and we didn't have El Niño in that year. You can see the index here, it didn't go over the higher limit to define the conditions. And then in the second year, in 2015, we had an El Niño with a lot of westerly wind burst activity. And so that taught us, and perhaps we can be more sober about prediction of extreme El Niño events now. And I went to the NME archive of the North American Multi-Model Ensemble to look at the plumes from these NME. These are the dynamic models that started in 2014, and we have the ensemble for that year, for each month, and the models took all of this, and they were very confident that there was going to be an El Niño at the end of that year. If we can see these predictions, they're from April and they go until November. And depending on the model, they were higher or lower. Whereas if you go to the forecast initialized on July, they were less confident that there was going to be an intense El Niño, but they still predicted El Niño conditions. We need to look at November, December in these graphs and these charts, because we move on in time. And we learned a lot from these about which are the exact ingredients to have an intense El Niño. And what we learned was that even if there are westerly wind bursts at the beginning of the year and the thermocline is increased, that is not enough for a severe El Niño. The westerly winds bursts need to continue perhaps until June, and only in July can we be sure that there's going to be an extreme El Niño. And this is summarized in this paper that is more recent, that shows with models and observations the correlation between those ocean measures. They take the ocean temperature, because when the thermocline is increased, it increases ocean temperature. And the most important line here is the black one, which shows the correlation necessary for an El Niño to happen. And what we can, I don't remember which year this paper from Jan Planton is, but the models have made a lot of progress in this. And what we can see that this correlation between the accumulation of heat and El Niño is low, is 0.4 at the most with a year of anticipation. So this is an indication that we need to be careful when we have these indicators in the ocean, but because they not always end up materializing in an extreme El Niño.
I would like to tell you a little bit about my research. This is how I'm interested in these forecasting issues and the duration of La Niña as well. And this is a record of Niño 3.4, including the latest El Niño, and the 97 and 2015 El Niño, and how we all know about this in the last few decades. There have been many Niñas lasting several years, 2-3 years. This allows us to study this type of event. These events are very important for our region. I'm from Argentina, the province of Buenos Aires, and we have droughts during La Niña events. And they have really impacted our economy in Argentina, at least, and I'm sure that they have also affected some other countries in the region. So can we really be confident about forecasting these events if we know the La Niña event will return or not the following year? This paper was written in 2016. We tried to predict if the 2016 or 2017 La Niña, depending on how you keep track of years, we tried to predict if the La Niña was coming back. In green, you can see the forecast. And they reached 2017, more or less, when we sent the paper to publication. So El Niño 2015, 2016, then it became La Niña in 2017, 2018. Sorry, in 2016, 2017. In this La Niña, we already noticed this global warming issue, what Michelle was saying earlier, because global warming masks La Niña because the ocean heats up, it's heating up, and if we do not define our climatology correctly, we might get it wrong, we might get the intensity wrong. And at the time, we weren't sure if the La Niña had taken place or not, but after some time, we realized it did. And we tried to predict if it was coming back for one more year. This was our prediction during the El Niño peak. We tried to predict the system's evolution 2 years into the future. And our model, in this case, the NCAR model, which is very much used in the NME, we moved it 2 years into the future. And here you can see
realizaciones de estas predicciones con el ruido
all
atmosférico,
the
el
realizations of
ensemble
the
mean nos
predictions with the
predijo
atmospherical
que teníamos
noise and
una
the
probabilidad
ensemble
bastante alta
mean.
de que volviera la
This
niña. Y aquí
predicted a
tienen la
high probability
distribución
of La Niña coming back.
del segundo año de este objetivo de
This is
predicción
a distribution of the second year. This was our prediction objective for the November-December, January season of 2017-2018, with a high probability of having a negative index and with low probabilities of El Niño events. This information, because now we know that La Niña lasts several years, this shows that after La Niña, it's not very probable for El Niño events to take place. And there's usually a high probability of having neutral conditions or negative conditions. As you remember, La Niña returned that second year. And what is important here? What does the NME do? If we have a look at the forecast for that year, I went back to the records. I'm showing you the dynamic models again with the value of the Niño 3.4 index initialized on March. The models predicted an El Niño event. And these are shorter term forecasts, not as the 2-year forecasts in our paper. In August, they were closer to the real scenario and they were predicting neutral conditions, but with the same models. The same models changed in their predictions between March and August of the same year. And this is a dramatic change. I'm sure many of you have seen or had this problem at the time because forecasts evolved dramatically. In September, we had Niña forecast. Of course, this is the same model, but initialized with different conditions. Things changed with the forecast that year. And when we initialized it at the peak of the El Niño, we were able to predict this La Niña return for a second year. So the model is, yes, we have dynamic models, they are publicly available, they can be used, but you need to really be an expert in the dynamics because the El Niño event takes place every several years. Whenever we have an event, it teaches us something new. And models need to be updated and improved. And these failed predictions help us learn to improve the models. And that's why we want to, we're organizing this webinar series to exchange these advances, to see if they're useful or not. Maybe we need to know also if this is useful or not, or how useful. Finally, a few weeks ago, I published this paper with WTW. They are an insurance consultancy firm. I provided 5 simple tips to use predictions. Maybe these tips are too simplistic for this community. I prepare them for the insurance community. They also use El Niño and La Niña predictions to anticipate catastrophes. These are very simple tips for interpreting dynamic and statistical models. And to include all these details that might make a prediction harder to make. So thank you so much. I'll be available for questions. Thank you.
Muchísimas gracias, Pedro.
Thank you, Pedro.
Con tu presentación.
An excellent presentation. So we've had amazing presentations about the scientific advances made and different questions regarding different areas regarding research. Now, we'd like to hear from the people that represent the regional climate centers of the WMO in the region. They've been working for over a decade with a clear mandate, contributing to providing climate operational information to support meteorological services. And these regional climate centers provide these services daily, and they work with all the data, the models, and the scientific advances as well. So now I would like to invite Dr. Cédric van Meerbeeck. He is an expert at the WMO Regional Climate Center for the Caribbean. He works at the CIMH. He will be talking to us about the evolution of the regional forecasting over time, and it's great to have this perspective from the Caribbean. Welcome, Cédric.
Thank you very much, Rodney. Can you hear me?
Yes.
And are you able to see my slides?
Exactly. It's
okay.
there.
Thank you very much. So let me get started. Thank you very much for the invitation to contribute to this really eye-opening webinar. I really learned a lot in the presentations that we've heard this morning and afternoon so far, depending where you are. Especially for us, I take home some messages for parts of the region that I will discuss with them, because I saw really important ways in which we can become more confident in our forecast going forward. But let me take a step back here, as suggested by Rodney. I'm not going to look at the science of El Nino predictability and predictions. I'm going to look at how confidence in regional seasonal forecasts, which you know in the Americas is often conditional upon El Nino or La Nina. How has this confidence grown over time? I'm not just talking skill, I'm talking confidence. So there are some attributes of valuable early warning information I want to first go through with you. And the first one that we're all familiar with is good quality. Good quality relies on a forecast, and observations require, of course, clean and homogeneous data sets, but also accurate, reliable, and sharp forecasts. And the latter is really to limit the level of uncertainty, which makes it easier to make a decision based on the forecast. The second one is equally important, if not even more important, when we take the science and build the knowledge into climate services, and that is how useful the information is. Some attributes here that are really important are the fact that it needs to be provided timely and at the right scale, that it is in an understandable common language. Common language does not mean there cannot be any jargon, but it does mean that jargon needs to be limited to the absolute minimum, and when it is utilized, not to confuse the users by using synonyms. Just make sure to educate the persons in the jargon that is absolutely necessary. And the most important is the information, of course, needs to be salient or relevant to the user and contextualized for the user. With those elements in place, it becomes really more actionable. Besides those attributes from the producer side, from the provider of the services, of course, we need to have manageable operations. And from an early warnings for all perspective, all the information needs to be available in a tailored way to all end users that are intended. But let me focus now on the first two elements, which is what really defines how users perceive confidence in the forecast, or how they feel confident about the forecast. So we're going to talk about quality in terms of skill, and usefulness in terms of techniques that we've employed over the years to improve the usefulness of the forecast information. So I'm going to do that in a couple of parts. First of all is what can the Caribbean Regional Climate Center and the Caribbean Climate Outlook Forum confidently forecast at the seasonal timescale at this present time. So we tend to look at 9 different hazard categories that we want to monitor and forecast. If we cannot provide a monitoring product, we will broker information that is available elsewhere. And for most of these elements here, you will find that we do provide some forecasts. So if we focus on the right column here, On the left, you find the timings of throughout the year where the frequency of the hazards is higher or lower. Higher means a more saturated color. But that means that our forecasts are needed throughout the year because we experience hazards, climate-related hazards throughout the year. So if we think about tropical cyclone activity as a seasonal activity, our skill, and this is really the forecast skill, if you were to base it on the Kendall's tau and then convert the number of the correlation coefficient to language, to English language, we could say that for tropical cyclone, the hurricane season and parts of it can be forecasted with moderate to fair skill. And you can see that for most of the hazard categories, we have at least moderate skill, if not fair to good. There are 3 exceptions. One is the categories evolving around surging and coastal flooding, which we do not currently forecast at the seasonal time scale. Fire weather, the same thing. We don't currently forecast it. We do monitor it. And Saharan dust intrusion, where we don't currently find useful skill in seasonal forecast. There is good skill at the weekly time scale, but not at the seasonal time scale. And it's important to draw that distinction here, whether a forecast is not made or whether it is simply that we don't have useful skill. I'll get back to that in a bit. So the next part then is how the CARICOF has improved the seasonal outlooks in the face of uncertainty with respect to the drivers of interannual variability. So what I'm going to do is I'm going to present 5 examples of how the Caribbean RCC and the National Meteorological and Hydrological Services in the Caribbean have worked together through CARICOF to achieving more confidence in the forecast from the user's perspective. So solution 1 would be achieving useful forecast skill throughout the year. And to that end, we know that there's the spring predictability barrier in El Nino forecasts. So what can we do to improve on year-round skill? And so what we did there is to try to build the most suitable or the best ensemble forecast to reduce the decrease in skill in certain seasons. You can see the spring barrier clearly identified here in March, April, May forecasts for, in this case, rainfall totals in the Caribbean. This is now using observed sea surface temperatures using the ERSST dataset. Whether we use the ERSSTs for the previous month, for the previous 2 months, or the previous 3 months, that spring predictability barrier will affect our forecasts for the year in a similar way. But what we see is that there is not really much gain throughout the year, whether or not we use 1 month worth of observed sea surface temperatures, 2 months, or 3 months. Importantly also is that the best skill typically is actually found in the summer season in the Caribbean. And that means that in this season, and also in the midwinter, we achieve better skill in general than in the middle of the dry season and towards the end of the wet season, which are MAM and SON. But we also looked at the skill scores that we could achieve if we were to use different predictor sets. And these are now forecasted predictors. So the left panel and the middle panel below is based on the National Multimodal Ensemble mean forecast that is made available by NOAA. The right one is utilize predictions of the expected rainfall totals for a 3-month period using the German model ECAM 4.5. In every one of them, and that is again linked to the ENSO predictability barrier, in the springtime, in northern spring, you do see a drop-off in skill for March, April, May. But what we take home from this is that perhaps we should also be looking at predictors such as the geopotential height and ECAM 4.5 or other model predicted rainfall totals, because the skill levels of individual forecast experiments will be very similar or better than those that are simply using the SSTs. So if we then build ensembles, we get convergence of evidence and we get hopefully the optimal skill that we can obtain. The second solution I wanted to discuss is, what do we do in case the driver is really unpredictable at seasonal timescales? So here we're thinking, for instance, of the dusty Saharan air layer intrusions into the Caribbean, which typically peak in the months of May, June, July each year, but can really affect the way the dynamics and the thermodynamics in the atmosphere play out, and therefore can significantly reduce the certainty on or the skill of a forecast. So if we look at it in a way that we presented at the last Caribbean Climate Outlook Forum in May of this year, we saw that ocean temperatures and land surface temperatures in the Caribbean were significantly above average, but definitely less so than the record years of 2023 and 24. So our typical predictors that we look at most are tropical Pacific temperatures, where ENSO was neutral, and the tropical Atlantic, which is currently unusually warm in the subtropics, but not so much so in the tropics anymore, in the tropical North Atlantic. But we do see a model forecast suggesting that the anomalies would be rather on the warm side, but definitely not record warm as it was last year. However, we don't really have the means to produce in a consistent way a seasonal forecast of Saharan dust and Saharan air layer intrusions. And so that leaves us with considerable uncertainty, because whenever there's dust in the atmosphere, that will tend to stifle deep convection and therefore shower and storm activity, but rather promote subsidence and therefore can aggravate levels of humid heat at surface, because the surface air layer in the Caribbean is very humid. So more humidity and higher temperatures. So what we then found as a solution that seems to resonate well with the audience, and this is a bit similar to what has been done for near, I believe, 2 decades in Central America, is to draw 2 scenarios. One scenario was infrequent Saharan air layer intrusions. Another scenario is what would happen if there were very frequent Saharan air layer intrusions. And then we predicate our forecasts and therefore our outlooks based on those 2 scenarios. The difference with Central America, as far as I can remember from joining the Central American Climate Outlook Forum several times early on last decade, is that we don't draw scenarios based on the forecast. We draw scenarios that will then modulate the forecasts. The third solution is to work towards impact-based forecasting to improve the effectiveness of early warning information. So one example there that we've been thinking through is, okay, we have considerable uncertainty about rainfall totals for the next 3 months. But if we think about drought as a hazard, it's a slow onset event, which means there's a long buildup into drought. And that long buildup allows us to combine observed rainfall totals with an uncertain forecast of rainfall totals. And the observation part is, of course, certain. So the more you can have observations before the forecast period, the lower your uncertainty in the forecast will be. And so the Karikov drought outlooks can tell me with up to 88% accuracy whether an impactful drought is expected by the end of the dry season, 6 months down the line. So with 6 months lead time and a discrimination score, an ROC score for those forecasters among you, of 88% is really quite a useful metric, because it allows for the user to have only very limited uncertainty as to, okay, which drought impact category and therefore which action level I should really be focusing on. And in that way, it is one of the first long-term impacts-based forecast products that we've ever been able to launch. The fourth solution is to build a storyline starting from the important implications of the forecast, rather than starting by telling the forecast and then maybe as an afterthought mention some implications. Now, we found that employing a newspaper article style is really ideal in terms of conveying the relevant information and building trust and authoritativeness of the forecast with the user community. So for instance, in Karikov, we release heat outlooks during the heat season, ahead of and during the heat season. And we start those outlooks by messages on the expected implications on different sectors that are affected by excessive heat. So this is an example, this slide here is an example of the messaging that we issue for the health sector. The fifth solution is to provide further details on how the hazards will play out. So this is really a weather within the season kind of forecast. So for instance, is there a chance for any flash flood producing extreme rainfall event or excessive rainfall event in the next 3 months? And so we've built a set of forecasts that can predict exactly that. This required some research, of course, to connect flood occurrence with the occurrence of excessive rainfall to uncover what is the most suitable threshold to use that would delineate or that will define what excessive rainfall that can lead to that can typically lead to the occurrence of flash floods in an island or territory should align with. So to sum up, some of the ways we've been able to improve confidence in seasonal forecasts for the Caribbean, and I highlight those solutions in green, which deal directly with improving forecast skill, are the following. So inclusion of other predictors into ensembles rather than just El Nino and La Nina, scenarios building where there are unpredictable predictors such as Saharan air layer intrusions, the development of impact-based forecasting, and a newspaper-style storyline for better contextualization of the forecasts. And then finally, weather within season forecasts. On top of that, and I didn't want to dwell on it because of time considerations, but I listed 5 other solutions that we've implemented. One was to blend the observations and the forecast that was actually mentioned for the drought outlooks. Another one is to build regression models with stations, with weather stations, where we know there's positive skill, and mask out forecasts of other stations. That masking out means that instead of producing an actual forecast, it's only going to use climatology for the best estimate for the climatology. So that's the mode. That's the let's just say that the average. The climatological average for stations where there's negative skill. Sorry about that. We also started utilizing generalized linear regression models as applicable. If you want to, for instance, calculate the count of tropical cyclones within a 3-month period, that number is theoretically unlimited. And so a generalized linear regression model that we could apply there is a Poisson regression versus the number of hot days, which is limited by the total number of days in a forecast period. In that case, we use binomial regression. And then two more, the sectors. One very important aspect is that we allow the sectors to define the minimum level of confidence in our forecast that they need to have before we message them out. So there are some forecasts we have too low confidence for specific sector users, and then we just do not focus on those forecasts. We just talk about those for which there is an adequate level of forecast from their perspective. Finally, I cannot overemphasize it, the importance of standardizing language, educating on strictly necessary jargon, and most importantly, avoid synonyms when messaging out forecasts. Thank you very much. You can find much more information on our products and services on our websites. Thank you for having me in this workshop.
Thank you very much, Cédric, for your excellent presentation and all these details that will be very useful for all the RCCs in the region, but also for our community and the research community. Thank you. And to continue, I would like to switch to Spanish y anunciar a nuestro siguiente representante.
And now I'm going to introduce our next representative from our Regional Climate Center from in CIIFEN, in the Regional Center to Research El Niño in Ecuador. And one of the members is Felipe Costa. Please go ahead, Felipe. Good morning, everyone. Can you confirm if you can hear me? Yes, go ahead. I'm going to, yes, we can see it. Okay, thank you. Well, first, thank you for having me. It's a pleasure to be here in this webinar. I also think it's a really important initiative, and the presentations so far have been really good and really relevant to understand the recent scientific advances we have had. And in my presentation, I would like to present about the regional planning we have had in our Regional Climate Center for the West of South America. And so how our understanding of the phenomena has been translated into or used by decision makers, and how it has turned into measures in different areas. And so for the lessons learned in our region, one of the problems we have had is that many of the experience is for the 2023-2024 El Niño event, which was a significantly severe event that really created alarm among the population. And so when the an El Niño or La Niña event is building up to or is ongoing, civil society already starts to mobilize, to plan, to try to understand what it is.
¿Puedes hablar un poco más cerca al micrófono? Porque se te están escuchando un poco bajo el audio.
Ok, déjame intentar.
O solo hablar un poco más fuerte, capaz.
Okay, can you perhaps speak a little louder? Or
Ahí
perhaps
se escucha
being
mejor.
close to the mic.
Mucho
Is it
mejor.
better?
Perfecto, adelante.
Ok, muchas gracias.
Great, thank you.
Bueno, entonces hemos identificado un problema
So we have found
las
an
personas
issue
tuvieron una proactividad para empezar
that
a
is
planificar
that
sobre los
people
potenciales impactos, pero
became
había una falta de
proactive
conocimiento sobre
to try
cuáles podrían
to
ser los
deal with the
impactos o cómo
impacts,
prepararse
but there was
para
lack of
estos impactos.
knowledge about the
En algunos
expected
casos
impact
se
and how
usaban
to get
algunas
ready.
asociaciones generalizadas, por ejemplo, de que en determinado
And so
territorio el
we had
niño trae
some
lluvias o la niña hace lluvias,
generalized links, for
que
example,
en
that
muchos
El
casos,
Niño
incluso
brings
quizás en la
rainfall,
mayoría de los casos
that
es
La
cierto,
Niña brings
pero no en
drought.
todos. Entonces, hemos visto que sí se
And
necesita
so
generar más
we have
conocimiento
found
sobre
that we
los
do need
potenciales impactos del niño
to
en las
have
distintas
more
regiones.
knowledge about the impacts of El
Seguramente
Niño
muchos de
in the
nosotros
different
hemos
regions.
visto en este El Niño 2023-2024
Probably many of us
esta
have
imagen.
seen
Este es solo un
in
ejemplo
2023,
de un
2024, in
estudio, un
relation
análisis que
to
hicieron
El
sobre la
Niño.
relación aquí, en este
We have
ejemplo del
seen a
niño,
chart
con la
like this one
precipitación. Se hizo un análisis
that
histórico
links
de
with
cuando hubo fenómenos del niño,
historic
cómo se comportó la
analysis of
precipitación, se generaron
how
promedios para
rainfall has
entender un poco el
behaved,
comportamiento
and
promedio
some
de las lluvias con
averages were
eventos del niño.
calculated
Entonces,
to look
hemos
at the
visto, por ejemplo,
average
históricamente,
behavior.
más
And so
frecuentemente,
we have
más
seen
lluvias en la región
more
costera de Ecuador,
frequent
norte de Perú,
rainfall
menos
around
lluvias en el norte de
Ecuador,
Sudamérica,
Peru,
parte de
less rainfall
Centroamérica,
in
en
the
fin.
north of South America and
Pero
parts
no
of
todos los niños
Central
son
America.
iguales. Entonces,
But not
tener
all
este
El
mapa
Niño are
para
the same. So
entender,
having this
comunicar y
map
capacitar
to be able to
tomadores de decisión,
understand,
personas que no
communicate,
son
and train
especialistas en el
decision
tema,
makers,
funciona bastante, pero ya
non-specialists
una
is
planificación
useful.
que
But
en un evento que ya está empezando y cuáles
having
serían
planning for an
los
event
impactos
that is already
esperados
starting
no
and to
es tan
look at the
adecuada, se podría
expected
decir, porque
events,
los fenómenos del niño o la
this would
niña
not be
son
so
diferentes,
adequate
como
for
hemos
that
visto
because the El
en las
Nino
presentaciones anteriores.
events are
Tenemos
different,
el
as we have
mundo
seen
considerado
in the other
central, donde la
presentations.
anomalía está
We
más
have Central
intensa en el
Pacific,
Pacífico
where
Central,
the
el
anomalies
niño
are
del
more
Pacífico
focused on the
Oriental,
Central
que la
Pacific
anomalía se
Ocean.
concentra
We have the
más
Western
cerca de la
coast,
costa de
where the
Sudamérica.
anomalies
También
are
puede
more
ser
focused
mixto, e
there. It can
incluso
also
los
be
términos también se pueden
mixed, and also
confundir.
the
También
terms
hemos
can be
visto el niño costero.
confusing.
Bueno,
We have
hay
seen the
diversos
coastal
sabores
El
del niño,
Nino,
como en un paper
and
se los identificó. Entonces aquí
we
traigo
have
una imagen
identified those.
de los resultados de la
And
tesis de
we
maestría
have the
de Johnny Moran,
results
que estuvo analizando
from
cuáles serían los
Johnny
diferentes
Moran's
modos
thesis,
de
analyzing
la
what would be
temperatura, los
the
modos
different
oceánicos de
modes
la temperatura
for
superficial del mar y su relación con
and
algunas
how they
variables
connect to
atmosféricas.
other
Entonces,
variables.
vamos a mostrar un poco más los detalles sobre
And we're going to
estos
look at some
resultados
of
en
the
una siguiente
details
diapositiva,
of
pero
these
bueno, aquí solo
results
para que se
and
pueda entender
now
que en la
in the
planificación es
next slides.
importante
But this is
tener en
just to
cuenta los
understand
diferentes tipos
that in
de
planning, we
fenómenos
need
del
to
niño.
take into account that there are
Algo que
different
también hemos
El Nino
identificado,
events, different types.
que bueno, creo que todos también
And one thing
conocemos
we have
esta
identified, I think we
clasificación
all
de la
know,
NOAA
is that we have this
y que es
NOAA
ampliamente
classification
utilizada a nivel
that
internacional,
is widely
que
used
considera un umbral de
internationally, and it
0.5
looks at a
grados de
0.5
anomalía de temperatura
threshold
superficial del mar, más
for
o menos, para el niño o
an
la niña,
anomaly
pero
in
que se necesitan
sea
que
surface
para que se
temperature.
declare
But
oficialmente
for
el
it to be
niño,
officially declared
5
as
medias
El
móviles
Nino, we
consecutivas,
need
de
5
una media móvil
mobile
es de 3 meses,
measurements
entonces
for
estamos
3
hablando de un periodo
months.
de aproximadamente
And so
7
we're
meses.
looking at a period of
Y hemos
approximately
visto que sí ha
7
pasado esto,
months.
entonces
And
en
we
algunos
have seen
casos se
that this
esperó
has
que se
happened.
cumpla
So
toda esta
at
condición para
some times
recién anunciar una
it was
condición, una
they
alerta
waited
por el
until these
niño o la niña.
conditions were met
Entonces,
to issue an
los
alert.
impactos que ya se empiezan a
And
sentir en
so
los
the
primeros
impacts
meses
that can
no
be
tienen una gestión o
experienced
planificación
in the
adecuada porque
first
estamos
months
esperando
are
todavía
not
una
adequately
declaratoria
managed
oficial.
because we are
Entonces,
waiting for
algunas
that
frases
official
o
declaration. And so
problemáticas que hemos
some
identificado es de que
problematic
estamos hablando de medios de
statements that we have
comunicación,
identified, and
instituciones de gestión de
we are
riesgos,
talking about the
incluso
media,
algunas
some
instituciones
risk
técnicas
management
científicas.
institutions, even some
Una frase
scientific
que
or
hemos
technical institutions. A statement that we have heard a lot is that El Niño did not reach the country because we didn't have the impacts that were expected or associated with prior events. In another region, they said that 0.3-degree anomalies above normal can already have impacts in rainfall. And so that we don't need to wait until we reach that 0.5 threshold in certain regions. And there were delays in the declaration for using the NOAA because of the fact that this NOAA classification was used. And so we were already experiencing the impacts, but we didn't have that declared, and there was no early planning. And so as for the publications, I would like to bring a specific example that I think is useful. During the 2023-2024 El Niño, we saw that many institutions used these references from CAF in our region from the year 2000 that bring challenges, proposals for the region from 1998. Even though it's an old publication, it was quite relevant and useful in the planning for the 2023-2024. And so this showed us that we need to have publications, documents about lessons learned, so that in other events we can have we can help with planning and with accessible language as well.
Oportunidades puntuales que nosotros vemos, como comentaba, Johnny Moran terminó su tesis de maestría.
Regarding other opportunities, Julián completed his master's dissertation, and he tried to find a way to detect these patterns of ENSO through machine learning and big data. We have seen that these results, part of the dissertation, they are preliminary results for the region, but they have huge potential, and I think they help us illustrate the issues I was mentioning before. In his results, Johnny found 8 ways. Here I only included 6, but he found 8 ways. For instance, more intense El Niño patterns, and what has been the correlation with precipitation in this part of South America. For instance, intense precipitations in 97-98 El Niño on the coast of Ecuador. But have a look at another ocean mode, the weaker Niño and more concentrated in the Central Pacific. We have a correlation, the opposite correlation with precipitations, because there were insufficient precipitations in part of the Ecuadorian coast. Some regions have a similar pattern, others have a higher variation. Therefore, it's important to understand as follows. Here there's a pattern that is similar to the latest ocean pattern we had, which was the La Niña Modoque in some cases, which leads to rains in the coast of Ecuador, given the dynamics of the ocean and atmospheric conditions. So rather than talking about El Niño causing droughts or floods in a given region, we should better understand how these different conditions appear. And this is much more complex than just saying something simple. There are many other variables. Marisol talked about the impact of the IOD, also the coastal Niño conditions, etc. So we should remember that we have this first study. Now we want to publish a paper with the results, technical and scientific analysis. If you're interested in being part of this development, please get in touch with us because we need more hands and more brains, most of all. And in the long term, it's important to have resources to make this an operational tool in order to implement this analysis in other regions of Latin America, because we need we need strong computing resources to process all this. In general, it's necessary to prepare and share more historical analysis of El Niño and La Niña events. For instance, there's this CAF publication that has been truly relevant in El Niño 2024 planning. Most of all because it talks about the impact on specific production sectors and also in the socioeconomic sector. We need to produce more information, but most of all disseminate specific inputs and recommendations in language that decision makers can understand. We've had excellent presentations today. I think that now the challenge is to share this knowledge through accessible language so that decision makers can make the most of it. Finally, I would like to tell you that at the CIIFEN, we have organized international conferences on the ENSO. Last year, we had the fifth conference. Sorry, the sixth conference to integrate scientific knowledge and by including decision makers and stakeholders that work in the area of risks. I'm telling you this so that you know what we would like to start planning the next conference that might be organized next year or in 2 years' time. But we need a number of stakeholders, we need to identify resources and also state which are the main topics to be addressed. This possibility of connecting science and decision makers in the same event. There's several ideas that I would like to that I'm sharing with you now so that we can reflect on this together. Thank you. Thank you, Felipe. Excellent presentation. A lot of food for thought regarding what we need to do in the value chain so that we can actually reach users, science, operations, and product dissemination. Now we have Laura Aldeco representing the Regional Climate Center for South America. This is a network regional center supported by the meteorological services of Argentina and Brazil, but also including all the other Southern Cone services. Welcome, Laura. Thank you. Thank you, Rodney. Thank you for this invitation. Let me just share my screen. Yes. Well, I would like to tell you about our experience at the Regional Climate Center in the south of America, in the south of South America. I work at Argentina's National Meteorological Service in climatology. I was going to focus my presentation on telling you about what we do regarding the ENSO and also how we implement this. And finally, I would like to think about what we identify as gaps or challenges we have in this regard. In particular, the Regional Climate Center of the South of South America started working in its demonstration phase in 2015. We started working a few years before that. But from the very beginning, we had a section that included monitoring El Niño Southern Oscillation. We have information in the 3 languages, and here we have the countries that are part of the center: Argentina, Brazil, and meteorological services. And we also have member countries: Bolivia, Chile, Paraguay, Uruguay. Although we all participate actively and with the national meteorological and hydrological services, we also include institutions that are associates or collaborators. And these are research institutes, universities, institutions that study the climate in each member country. And I will mention this again at the end. Here you can see the CRC SAS website, where you can find the El Niño La Niña reports in the monitoring section. And there you can find several products. Here in this section, you can find the El Niño La Niña reports. We write this in 3 languages: English, Spanish, and Portuguese. It's a PDF file that you can download, and ideally we try to keep it up to date. We update it every month. This report presents the results of monitoring several ocean and atmospheric variables. And here you have a few examples of what we study. We have a monitoring section, and towards the end, we focus on forecasting for the coming quarter. These are the sources we use. We might be missing a few of them, but here we have the main global centers and all the information we try to include that is available, free, and that's really good. We work quite a lot with the ERI forecast in both versions, ensemble and probabilities. We also analyze other forecasts, such as the Australian Meteorology Department, sometimes APEC as well.
Este informe no solamente queda en el informe, se hace, se publica y listo.
So we prepare the report, we publish the report. But also, we apply this El Niño monitoring when we draft climate predictions reports. And these reports are prepared in a monthly meeting of the different CRC member countries. So first of all, we have monitoring of typical variables, precipitation, and temperature in the previous months. We also monitor the global conditions, Niño, Niña, neutral, what the forecast is. And at the time, we also started monitoring some sub-seasonal scale indices. In particular, we include the Manin Julián monitoring and the Antarctic one. At the end of the report, we have the result of integrating all this, and we have quarterly forecasting for the entire region. Each country has its official forecasting, but still in this meeting we share this data, and the results are published as the quarterly forecast for the region. So it is true that we do consider the state of El Niño, La Niña, or a neutral phase. And now I would like to talk about the challenges we
a la hora
find
de ver dónde podemos hacer mejoras, qué
when
nos
it
falta.
comes to
Y bueno, empiezo
to
primero
improving our work.
que
Challenges.
y estuvimos viendo que también, bueno, quizás tenga que ver un poco con lo que mencionó, lo que contaron
And maybe this has to do with what
Michelle,
Pedro,
del
Michelle
nuevo índice,
said, this
sí,
new
pero
index.
antes de saber de la existencia del RONI,
But
nosotros ya
before
veíamos
we
que
knew
en
about
algunas
the RONI
situaciones
index, we knew that in
no
some
había tanto acuerdo entre
situations
los principales
there
centros
was not
globales del
much
clima a la hora
agreement
de
among
definir
the
un
different
evento del
climate
niño.
global centers when it came to
Quizás
defining
uno
an El
entraba
Nino
a
event.
la página web de
You
un
might
centro global y encontraba que
read
las
some
condiciones eran
global
neutrales.
center
Entrabas a la
website
página
and
de
they
otro y
said that the
encontraba que
conditions were
definían el
neutral.
evento El Niño o La
Another
Niña.
institution said
Por
that
lo
there
general
was
también
an El
se
Nino or La Niña
pareció
event
que
occurring.
estas situaciones se daban más
And
quizás
this
cuando
situation
las
was even
anomalías
more
de la temperatura o
frequent
el mar estaban como muy en
when
el límite
temperature or
o
sea
algo por el
anomalies were
estilo.
borderline or something
Pero
like
el
that.
problema es que a nosotros como
However, the problem
servicios
is that
meteorológicos,
as meteorological
esto
services,
nos genera un poco de incertidumbre.
this
Sabemos que las noticias vuelan y
affects our
como cuando se
confidence
filtra de algún lugar que va a haber un
because
niño o una niña,
news
los usuarios
flies,
empiezan
and when
a
people
tirar
find or users
respuestas
find out
y
that
muchas
there
veces no
is
estamos
going to be
seguros
an El Niño La Niña
de
event, users
cómo
want
responder,
answers, and
¿sí?
many times
ante
we do not
esa
know how
falta
to
de
answer
consenso a nivel global.
when there is a lack
Y
of
bueno,
global
también a nivel regional
agreement.
pasaría algo similar.
Well, something similar happens
Después,
regionally.
respecto a la habilidad del pronóstico, si bien nosotros
Regarding
lo
the
miramos de
forecast
manera
skill,
cualitativa, ¿sí?
although
Sabemos
we assess
pudimos
it
ver que en general la
qualitatively,
habilidad del
we were able to
pronóstico
see that
trimestral suele
the
mejorar
quarterly
cuando hay alguna de
forecast
las fases del niño,
skill
un niño, una niña,
improves when
que
there is a
module un
Niño
poco
Niña
la gran
event
escala.
that
Pero como también
modulates the
mencionó Felipe,
conditions at a larger
es
scale.
sería bueno
But also, as Felipe
mejorar toda la
said,
parte de la
it's
comprensión
important to
de la interacción
improve
entre estas escalas, ¿no? La
our
escala
understanding
subestacional
of
y la
the interaction
estacional.
of these
Si bien la
scales,
subestacional
seasonal,
la empezamos
seasonal
a
and
monitorear,
sub-seasonal. We
monitoreamos, la
have started
miramos,
monitoring the
pero
seasonal
no estamos
scale.
seguros
However, we are not
quizás de cómo
sure
aplicar eso
about
o
how
cómo
we can
utilizarlo para mejorar
apply
el
or
pronóstico
use
estacional.
that to improve
Bueno, justo
seasonal
Marisol mostró
forecasting.
algo súper interesante que es la combinación de
Marisol
Venus,
showed
de
us
las lunas
something
fase en
very
Venus, con
interesting, which is
algunas
a
fases del
combination
hemisferio
of the
límbico. Esa
ENSO
información es
phase and
buenísima
the
y
IOD
estaría bueno
phases. That's
tenerla.
amazing information,
Quizás en
and it would
alguna
be very
parte de la
useful to
página web
have it. Maybe somewhere on the
puede tener
website
transferencia, pero
or
ese tipo de
through
información
a
creo que nos
transfer,
sirve un
file
montón.
transfer, we could get that information.
Bueno,
I
y en
think
el
it's very
último
useful.
del punto de esta diapositiva,
Finally,
quizás nosotros como CRC
maybe
podríamos
as the
incluir algo de
CRC,
información
we
adicional
would be able to
vinculada
include
a
additional
tareas
information that
como
has to do
quizás
with
composites
the ENSO.
regionales,
For
las
instance,
precipitaciones,
regional
la temperatura media
composites.
para casos niño, niña,
Precipitation
y o
anomalies,
en
mean
combinación con otros
temperature
parámetros
for
como indicadores
Niña
límbicos
and
que
Niño
fue
cases
como lo
or
mencionó
events, and the
Felipe
combination of
probablemente en la
other
sesión.
aspects for
Y
the
por último,
IOD, as I
pero
said a
no
minute
por eso
ago.
menos importante,
And last but not least,
nosotros, como ya mencioné al principio,
as I said at the
trabajamos
beginning,
por suerte bastante con la
we
parte
fortunately
académica.
work with
Sabemos
the
que hay servicios
academia quite a
meteorológicos,
lot.
quizás no disponemos
We
del
know that
tiempo
meteorological services
para
might not have the
dedicarnos
necessary
única y
time
exclusivamente a
to
la investigación, al desarrollo de
uh,
productos.
research or
Entonces,
develop products
esa
and just
conexión con la
that.
parte
So that
académica
connection with the
es
academia
importantísima.
is very important for us.
Nosotros tenemos experiencia en
We
interacción
have
con lo
experience
académico
in
dentro del marco de los proyectos. Por lo
interacting with the
general, conocemos
academia,
algunos
usually
ejemplos
within
como
projects.
Climar,
For
SIISA, bueno,
instance, Climar, CIISA,
estaba enfocado en lo que era pronóstico estacional
Climar
y subestacional,
focused on
SIISA
seasonal and
para las sequías,
sub-seasonal
y bueno, ahora
forecasting.
el que actualmente
CISA
está
focused on droughts.
en marcha es en Andes Más.
And now
Acá puse un
the project in
ejemplo
operation
de
is in
cómo
Andes
fue
Plus.
esta
This is
transferencia,
an
algo
example
que
of this
benefició
transfer.
a toda la región, ¿sí?
a transfer that benefited the entire region. That's seasonal forecasting, CLIMAT, developed by Marisol Osman in her PhD thesis. So other projects, CLIMAT, SIISA, enabled us to transfer this calibrated seasonal forecasting. And now we have a forecast for the entire region that is run every month, and it's operational now. In this sense, we think that we need to continue working. Thank you so much.
Muchísimas gracias, Laura. Pues ha sido una
Thank you so much, Laura.
muy rica en conocimiento.
It has been a truly rich webinar regarding knowledge, perspectives, and the objective of this webinar has been fulfilled because now we have very interesting information about what's happening in science and about what we still need when it comes to connecting dots in the operational area. But there are also many opportunities. We can continue this conversation because the WMO's regional climate centers have this combination of the tools and different perspectives, and that how this can help us provide better services for the community and also to support national meteorological services. We must compile these main takeaways that we have included in these 2 hours and 15 minutes. We still have almost 500 people in the audience, and this shows us how interesting this debate is. So we have the interest of the scientific community and the operational community. Something very important mentioned by Michelle at the beginning. NOAA's definition of El Niño was drafted for the United States. Let's remember that. And nowadays, countries and regional climate centers need to find ways to adapt this indices and methodology to adapt to the early warning needs of countries.
And Ana has asked me to give some closing remarks, but because Ana had to be at some other event. But I would like to thank Pedro for his help building this bridge between the scientific and technical community. We have leaders from the scientific community who have been working tirelessly on this, and also people from the professional side. And thank you to everyone who took the time to join us today. We're going to prepare a summary that captures the main messages and that identifies the opportunities for collaboration, for integration that can benefit the scientific and the operational community in benefit, of course, of the whole of society, which is we all want, of course. Thank you to the interpreting team. Thank you to everyone who has been working on this behind the screens. We are very happy with the attendance we have had today, and thank you so much for our scientific leaders, our climate people who are on climate. Thank you, everyone.